In this example, we're given some information about the graph of an ellipse, and we're asked to write down the equation for the ellipse. So although we aren't shown the graph of the ellipse, we're just given some information about what the ellipse looks like. I'm going to go ahead and roughly plot some of the key points on the ellipse on this set of axes that I've drawn here, because we're told that the vertices of the ellipse are located at 4 and minus 4 on the x-axis, and then the two foci or foci of the ellipse are located at minus 2 and 2 on the x-axis. So since the foci of an ellipse are always on the major axis of the ellipse, and of course the vertices of the ellipse are the endpoints of the major axis of the ellipse, then we know that this ellipse is elongated along the x-axis. And furthermore, since these vertices are symmetric around the origin and the two foci are symmetric around the origin, then that means that the center of this ellipse must be the origin. So that's good, because we know what the equation for an ellipse with center at the origin and major axis along the x-axis must look like. That's the same equation we've been practicing in the previous examples. So we know that equation looks like x squared over a squared, where again a or plus or minus a are going to be the y-intercepts, the x-intercepts of the ellipse, plus y squared over b squared, where plus or minus b are going to be the y-intercepts of the ellipse. That's equal to 1. And since we already know what the x-intercepts are, they're plus or minus 4, that tells us, of course, here then that a must be equal to 4. And since we know that the foci of the ellipse are located at plus or minus 2, that would be plus or minus c along the x-axis, then we know the value for c here must be 2. And now we can use, again, our familiar relationship between these values a, b, and c to determine the value for b, so we can figure out what the two y-intercepts are, and then this quantity b squared that we need to substitute in to this equation to complete this equation. So let's see, c squared is 2, so let me write 2 squared here, and that must be equal to a squared, so that's 4 squared minus b squared. So I simply need to solve this equation for b. So I have here that 4 is equal to 16 minus b squared. And then rearranging the terms in the equation a little bit, we get that b squared is equal to 16 minus 4, which of course is 12. So we know here then that b is equal to square root of 12. So that tells us that the y-intercepts are located at approximately plus or minus 12 on the y-axis. But since we're not graphing this ellipse, the exact location of those y-intercepts is not really that important to us, because all we really need here is b squared to complete the equation. So let me complete it down here where I've got a little bit of room. So we know the equation is going to be x squared over a squared, but a squared would be 16, right? That's 4 squared. Let me write this as 4 squared, plus y squared over b squared. So that's going to be the square root of 12 squared is equal to 1. And now if we just simplify a little bit, we get that x squared over 16 plus y squared over 12 is equal to 1. And so there's the equation for the ellipse that's described in this problem.